Welcome. In Chapter 3, we will discuss in a more in-depth approach the atomic structure and the different components of an individual atom. In the last chapter, we discussed how, in Dalton's theory, they thought that the atom was the smallest individual unit and that it was indivisible. But in the late 1800s, a variety of different experiments using electricity were conducted that showed a lot more information about what actually an atom consists of. During this time, they learned that matter has electrical properties and that these electrical properties play an important role in how the different parts of an atom can interact with each other. The emergence of electrochemistry is what allowed a lot of the discoveries to occur on the individual components of what makes up an atom. Humphrey Davey was a key player in this discovery of several new elements through the use of electricity. He found that when you put a molten substance of sodium hydroxide or potassium hydroxide into an electrical current, the ions would split apart from each other based on their charge. In order for us to understand this experiment in a little more detail, let's go through some terms. The first term, electrolysis, is the splitting of a compound using electricity. This is occurring because of an electrolyte. An electrolyte is a compound that conducts electricity when it's molten or dissolves in water. This solution will then carry an electrical current, and the electrical current is carried through a device called the electrode. The electrode is a carbon rod that is able to carry the electrical current to the solution. Finally, we have an anode and a cathode. An anode is going to carry a positive charge in solution, and a cathode will carry a negative charge when it's in solution. And then finally, we have an anode and a cathode. An anode will carry a positive charge when it's in solution, and a cathode will carry a negative charge when it's in solution. In this schematic, we have an electrolysis apparatus. An electricity source can be applied, and the electricity will flow through, the electrons will flow through the wire from the anode to the cathode. What then occurs is the cathode will maintain a negative charge, and an anode will maintain a positive charge. The cations, or the positively charged molecules, will be attracted to the cathode, which has a negative charge, and the anions, or the molecules that have a negative charge, will be attracted to the anode, which has a positive charge. This migration of ions using the flow of electricity is what allowed the discovery of some of these purified metals. So just to reiterate, an ion is a group of atoms that has some sort of charge, and those ions can be diverted into two categories: anions, which have a negative charge, and cations, which have a positive charge. In 1897, Joseph Thomson performed an experiment that would show that atoms were composed of a particle called an electron. In this experiment, a cathode ray tube was used. A cathode ray tube occurs when a metal electrode is placed in a sealed tube and connected to a vacuum pump so that most of the air is removed from it. It was observed that a green fluorescence was obtained when a strong electrical current struck a screen that's made of zinc sulfide. When this cathode ray was placed between a negative plate and a positive plate, the ray, the green line that you see here, started to push towards the positive plate and repel from the negative plate. This particle acted the same exact way regardless of the material that was used. And what this showed was that an atom is built with a unit called an electron that is negatively charged. This unit is attracted to a positive charge and repelled by a negative charge. In 1886, another experiment was performed by Eugene Goldstein, which showed the existence of a positive particle. In this experiment, a cathode ray tube was also used, and they found that electrons were formed and sped towards the anode, but positive particles were also formed and shot in the opposite direction, towards the cathode. These particles also had a different mass depending on the substance that was used. And the lightest gas, hydrogen, were shown to have particles that had a mass 1,837 times that of an electron. In 1909, Robert Millikan was able to determine the charge of an electron using an oil drop experiment. In this experiment, an atomizer was used to release a drop of oil through a positively charged plate. The drop of oil was then irradiated with a source of ionizing X-ray radiation, and then the charge of the oil drop could be determined by the applied voltage and the mass of the oil drop. The charge of each drop was some whole number of electrons. Between these two experiments, a conclusion was drawn that an electron must be part of an atom, or a subatomic particle. Millikan's charge of an electron experiment and the Thomson mass charge ratio of an electron combined determined that the mass of an electron was extremely, extremely small. And since the mass of an electron was smaller than the lightest atom, then it must be a subatomic particle.